You catch a ball. You see a flash of lightning. You hear your name called from across the room. Each of these moments feels instantaneous, a perfect snapshot of reality as it happens. You are here, now, experiencing the world in real time. But you're not. By the time any of this information reaches your consciousness, the event itself is already over. It's a memory. You are and have always been living in the past. Think about the simplest possible event. Light hits an object and reflects into your eye. That light takes time to travel, a tiny amount, but not zero. The signal then has to be converted by your retina into an electrical impulse. That impulse has to travel down your optic nerve to the back of your brain. Your brain then has to process that raw data, cross-reference it with everything you know, and build a cohesive image you can consciously perceive. Each step takes time. It's not much, maybe 80 milliseconds, about the length of a single frame in a movie. But it's there. You are never seeing the world as it is. You are seeing the world as it was about 80 milliseconds ago. Sounds simple, right? A slight processing delay. But that's not the whole story. And honestly, the real reason is far stranger. Because your brain isn't just passively receiving a delayed signal. It's actively lying to you about the timing. In 2000, neuroscientist David Eagleman, then at the Salk Institute, published a paper on what he called the flash lag effect, and it completely breaks our intuitive sense of the present. Imagine you're watching a dot move across a screen. At the exact moment the dot passes the center of the screen, another dot flashes right on top of it for an instant. Now, where do you see the flash? Logically, you should see it right on top of the moving dot. But you don't. Almost everyone sees the flash lagging behind the moving dot. Why? Because your brain knows it takes time to process visual information. So, for moving objects, it doesn't show you where they are. It calculates their trajectory and shows you where they're going to be in about 80 milliseconds. It literally pushes the moving object into the future to compensate for your own processing delay. But the flash is unpredictable. Your brain can't anticipate it, so it just shows you the flash where it actually was 80 milliseconds in the past. Your perception of a single moment is a mashup of a past event, the flash, and a predicted future event, the moving dot. Your brain builds a reality that is physically impossible, and it presents it to you as the present. Think about that for a second. The now you experience is a carefully constructed fiction, edited for coherence. But here's where it gets even more complicated. Not all of your senses move at the same speed. If you clap your hands in front of your face, the light from that event reaches your eyes almost instantly, but the sound takes a few milliseconds to reach your ears, and the feeling of your hands touching takes even longer to travel up the nerves in your arms to your brain. You're receiving 3 different signals about one single event at 3 different times. And yet, you experience it as a single, perfectly synchronized moment. A clap. How? Your brain pulls off an incredible trick. It waits. It collects all the data from your different senses, and only after the slowest signal has arrived does it decide what happened. It essentially buffers reality. Neurologist Patrick Haggard at University College London has demonstrated this in countless ways. He'll have subjects press a button that causes a light to flash. If he secretly inserts a tiny delay between the button press and the flash, people's brains will adapt. They will start to perceive the flash as happening before they even press the button. Their brains literally reorder time to create a cause and effect story that makes sense. It's a constant process of collecting, holding, and editing sensory data before it's ever released to your conscious mind. The seamless present you feel yourself inhabiting is an illusion, stitched together from past events that arrived out of order. So, okay, we live in the very recent past. A fraction of a second. Maybe this is all just a neat bit of trivia. A few milliseconds here, a few there. It's a processing delay, not a time machine. It doesn't really change anything about our experience of life. Our reality still feels real, immediate, and under our control. That seems like a pretty good answer, right? The common sense explanation. Well, not quite. Because the delay isn't just about perceiving the outside world. It's about your own actions, your own choices. And the truth about them is much harder to accept. In 1983, a neuroscientist named Benjamin Libet at the University of California, San Francisco, ran an experiment that people are still arguing about today. It was simple. He put participants in a chair, hooked them up to an EEG to measure their brain activity, and asked them to do one thing: flick their wrist whenever they felt the urge. He also had them watch a special, fast-moving clock and report the exact moment they first felt the conscious intention, the decision to move. What he found should be impossible. The brain activity that initiated the wrist flick started a full half-second before the person felt the conscious urge to do it. Let me say that again. Your brain begins preparing an action about 500 milliseconds before you are even aware you've decided to take it. There's a flurry of neural activity, a rising wave that neuroscientists call the readiness potential. Then, about 200 milliseconds before the muscle actually moves, the conscious decision pops into your head. It feels like you're the one driving. But you're not. You're just becoming aware of a decision that was made for you unconsciously moments before. Your conscious will isn't the cause of your action. It's one of the last things to happen in the chain. It's a press release, not an executive order. Think about what that means. You reach for a cup of coffee. You thought you decided to do that just now, but your brain had already set the wheels in motion before you had the thought. You felt the conscious urge, and you thought it was the cause, but it was just an after effect. The decision was already made. You're not just perceiving the world in the past. You are experiencing your own free will in the past. You are, in a very real sense, the last to know about your own intentions. This finding has been replicated dozens of times. In 2008, neuroscientist John Dylan Haynes at the Max Planck Institute used modern fMRI scanners to push it even further. He could see brain activity patterns that predicted a person's random decision to press a button with their left or right hand up to 10 seconds before they were consciously aware of having made the choice. 10 seconds. A pattern of neurons fired in your brain that determined what you would do, and for 10 full seconds you walked around thinking you were still undecided. This isn't a minor delay. This is a fundamental reordering of how we think about ourselves. We feel like a unified self, a pilot in the cockpit of our body, making decisions and then executing them. But the science points to a different model. Your brain is a massive, parallel processing machine running countless unconscious programs. Your conscious mind is just a small window, a narrator that looks at what the machine is already doing and comes up with a story about why. I decided to get coffee. It's a good story. It feels right. But it's a story you're told after the fact. So when you catch that ball, you're not just seeing the ball as it was 80 milliseconds ago. Your brain predicted its path, pushing its location into the future. Your decision to move your hand was initiated by your brain a half second before you consciously felt the urge. Your arm moved. Your brain collected the out-of-sync signals of sight and touch and sound, held them, edited them for coherence, and then presented a single, unified story to your consciousness. A story called, "I just caught that ball right now." And every part of that story is a lie. It's a necessary lie. A beautiful one. It allows us to function, to navigate a world that's too fast and too complex for our consciousness to handle in real time. But it is a fiction. We are not live streamers of reality. We are spectators watching a film that was shot, edited, and scored by the unconscious parts of our brain, and then presented to us as if it's happening live. Every moment you have ever felt yourself living in, every sunrise, every first kiss, every single now that has made up the entire fabric of your life was already an echo. You're not living. You're remembering